Hello, good morning, everyone, and welcome to day 2 of the 2025 AIAA SciTech Forum. I am Sam McGill, and I'm currently serving on a detail as the Strategic Communications and Partnerships Manager for the Aerospace Operations and Safety Program within NASA Aeronautics. And it's my pleasure to serve on the SciTech Guiding Coalition again this year. Today at SciTech, we look forward to opening the Expo Hall. It'll be filled with a range of transformative technologies and solutions from more than 100 leading companies, universities, and government agencies. In fact, like the attendance here, it's the largest exhibit hall in AIAA history. Woohoo! Many of these exhibitors are looking for top talent to join their teams. Shout out to the students here. You can visit the hub and hear short talks on the stage beginning at 2 p.m. in the Expo Hall. You can also check everything out during the reception starting at 5:30 p.m. As you may have noticed, I see some folks out here, it's wear your team colors today. I'll try to find something appropriate later. If you're not already, we encourage you to wear your gear or colors from your favorite team tonight at the reception. It could be your alma mater, your professional sports team, your organization, or your hometown league. We expect that this will generate lots of great conversations. As we begin the program this morning, we remember our theme this week, Energize the Future. And when the Guiding Coalition considered what we should cover each day of the forum, we knew we wanted to focus one day on design and development. With advances in digital engineering and systems engineering, as well as new approaches to design for testability and manufacturability, we knew this topic was ripe for discussion. We couldn't think of a better way to begin this action-packed day with a keynote address from Kristen Baldwin. She's Deputy Assistant Secretary of the Air Force Science, Technology, and Engineering in the Office of the Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics. As you can see, she is joining us via Zoom. I think is she up here yet? There she is, Kristen. But she will be here at SciTech later today, so you can engage with her later today. She wasn't going to miss the excitement and energy with you all. Ms. Baldwin's bio is extensive, and currently she provides guidance, advocacy, and policy for the Air Force's annual $3.1 billion science and technology program and the $1.9 billion developmental, prototyping, and experimental program, conducted at more than 60 research sites worldwide. So that's about $5 billion she's in charge of. That's a lot. In addition, she provides engineering and technical management direction on digital engineering, cyber resiliency, capability development planning, and the functional management of more than 22,000 military and civilian scientists and engineers. She also provides technical advice and counsel to the Air Force Acquisition Executive on a broad range of engineering and technical management area. She oversees the Air Force International Science and Technology Outreach as well. Prior to her current position, Ms. Baldwin served as Deputy Director for Strategic Technology Protection and Exploitation in the Office of the Undersecretary of Defense for Research and Engineering, where she led DoD efforts to maintain technology advantage by mitigating exploitation and vulnerabilities of critical missions, programs, technologies, and the industrial base. Ms. Baldwin has also served as Principal Deputy Systems Engineering in the Office of the Undersecretary of Defense, Acquisition, Technology, and Logistics, where she established DoD policy and practice for digital engineering, systems security engineering, systems of systems engineering, trusted microelectronics, anti-tamper, and software assurance. There you go. She has been a champion of digital transformation, obviously. She's been a champion with AIAA and within the Department of Defense. She will share insights into the DoD's digital transformation strategy and implementation progress across all the services, including opportunities for industry collaboration. She'll also provide an update on the digital material management efforts, including progress on the DMM Industry Association Consortium. When she concludes her remarks, I will join her back on stage and we'll take questions from the audience. Please use the QR code as you have been doing so well since yesterday. Hopefully you'll continue to, and upvote those questions that you find interesting. So please join me in welcoming Kristen Baldwin to the stage. Thank you.
Thank you so much for that wonderful introduction. I really regret the weather did not permit me to be able to be with you this morning. But as was mentioned, I'm hopping on a flight right after this and hope to be with you very, very soon. It's really an honor to be able to address you this morning and connect with all of the organizations, the communities that AIAA represents and brings together in this annual forum. I'm going to, I'll go ahead and start with my first slide. I want to share with you a little bit about the organization that was mentioned in my introduction. Our organization symbol is SAF-AQR, Secretary of the Air Force for Acquisition. And as was mentioned, my role is to oversee the science, technology, engineering portfolio. And I just wanted to highlight to this technical audience the key priorities that we have as science and engineering for the Air Force. Starting at, and these are in no particular priority order, but just starting at the top left, in that investment that was mentioned in my introduction of annually $3 billion, we really want to make sure that we maximize the effectiveness and the ability of the technology, the S&T that we are investing in, to transition to real meaningful operational capabilities and advances for the Department of the Air Force, which is the Air Force and the Space Force. So what we're doing is we have a real focus on connecting our science and technology and innovation opportunities from across the commercial science and engineering ecosystem with our Air Force and Space Force mission priorities. And doing that, we are advancing our technology transition practices and our use of prototyping and experimentation to really hone and reduce risk of technologies so that they can be more easily implemented and transitioned into our capabilities. Moving along to the next priority, just keep on that slide, is to strengthen our resiliency of our weapon systems, particularly from cyber attack. And this extends not only in the design of our engineering design for resiliency to be more resilient to cyber adversary tactics and exploits, whether they be through hardware or software. But what we're also really doing is having a focus on protection of the technology as that technology is developed, as those prototypes and experimentation activities are acted upon. We are extending that cyber resiliency focus through not only just acquisition and program management activities, but all the way into the science and technology and research protection. So a lot going on there. Moving just around clockwise, we have a very strong focus and responsibility to grow and advance and continue to develop our science and engineering talent. We have a strong STEM program and outreach. In fact, last year we just republished a new 10-year plan for STEM outreach. And we want to continue to champion not only the development of our talent, but the tools and techniques that can embrace and enable our talent, which really does bring us to the main priority of my topic, which is going to be about our digital transformation. We're doing that by ensuring technical rigor throughout our science, technology, and acquisition processes. We conduct independent technical reviews and bring to bear subject matter experts that can provide our programs with insights and peer reviews throughout the life cycle. And we're really transforming our culture of science and engineering in the Department of the Air Force to embrace digital engineering, open architectures, and agile software development practices. So these priorities focus all of our activities in my organization, and I'm going to go a little bit deeper into digital transformation now. Next slide. So regarding digital engineering, why is this so important? Well, this chart depicts a study, some findings of compiled by a study that was done by the Hudson Institute and published in 2021, which took a look back in the history of Air Force programs and identified that and has mapped out since World War II the timelines for delivery of Air Force programs from then until now. So now we are on an average of about 16 years from concept to delivery of a new capability. We are in a competition with peer competitor nations, and in particular, China is now on par to be able to deliver new capabilities within a 7 years or even fewer. And so we see digital transformation as a true disruptive business practice that we can bring to bear to help to accelerate our ability to compete in time. We have to invest now in how we acquire capabilities, not just what we are acquiring. Next chart. Our digital transformation in the Department of the Air Force is built on a strong foundation of digital engineering practices and strategies. This chart depicts quite a number of logos, and I'll just orient you to the ones that I want to highlight. Kind of top center is the DoD Digital Engineering Strategy. This was published in 2018. And has 5 basic pillars that have been continued to provide foundations through today. So the DAF, Department of the Air Force Digital Materiel Management strategy and implementation is fully embracing of these 5 pillars, and they've proven to be very enduring. On the sort of in the middle row, you'll see on the left-hand side a depiction of the digital engineering framework that has now been published by the Office of the Undersecretary of Defense for Research and Engineering in a policy, DoD Instruction 5000.97 for digital engineering. This policy requires implementation of digital engineering and treatment of digital engineering approaches in all of our program acquisition strategies. So now we have not only just the strategic foundation, but the policy requirements for all of our acquisition programs. And then moving on across the middle to the right-hand chart is a depiction of that is being implemented by our development, test, and evaluation community of digital engineering, test and evaluation, and modeling and simulation as a continuum. So fully embracing digital technologies and model-based approaches so that we can actually have a more continuous engagement by our testers, our engineers, and our analysts to provide a continuum of knowledge that grows over time to inform all decision makers. And then across the bottom of this chart depicts publications that have been made by the military departments, the Army and the Navy, and then the Air and Space Force, of their individual, very service-specific digital strategies. So this has really been using that foundation of those 5 principles, really been embraced by all of the DoD components I didn't even mention Missile Defense Agency, which is listed here and is a key partner. We're also partnering with our international partners, particularly the Australia and the UK have both also published digital engineering approaches and strategies, and they build on these common foundations. This provides this consistency provides a real true opportunity so that we can have unprecedented engagement with our to bring together the joint force and joint warfighting concepts with and allies, but also critically with our industrial base. Let me go to the next chart. And I want to highlight for you the Air Force's digital material management approach. The logo shows 6 key underpinning pillars of the digital material management approach. And this slide actually has 2 QR codes. One will take you to a white paper that describes all of these pillars, and the other QR code will take you to a video, which we're actually going to play for you right now.
Imagine the Air Force Materiel Command operating like a cutting-edge smartwatch. With trusted data and real-time notifications, the latest technology provides precise information faster. And its seamlessly integrated functions offer extensive capabilities as part of an advanced digital ecosystem. This is where we're heading at AFMC. Our aim is to accelerate capability delivery through a fully empowered digital workforce, equipped to deliver integrated, innovative, and trusted capability across the life cycle with unprecedented industry and government collaboration. This is Digital Material Management, or DMM, and it's enabled by 6 key initiatives. Take a closer look at each DMM initiative. We are committed to structuring and securing our data. Models and data are easily shareable across the lifecycle, Air Force Acquisition Enterprise, and industry partners, because they're cleanly organized and fit our unique needs. Those same models and data are secured by measures that protect us from adversarial attacks. Providing access to DMM tools. Airmen work efficiently because they have access to the right digital tools when they need them. Training our digital workforce. Thanks to functionally tailored and streamlined digital training offerings, every individual has skills perfectly tuned to and evolving with their role. Instilling a digital-first culture. As airmen move from obsolete to digitally driven processes, they're enthusiastically embracing change and proactively sharing ideas for improvements. Developing digital strategies. Programs and organizations share a common vision of applying digital-first strategies to their work and feel confident with the tactical plan and milestones to get there. Their strategies and actions are aligned with the overarching enterprise. Modernizing IT infrastructure. An upgraded IT infrastructure, characterized by speed and agility, is the foundation for progress in the other initiatives and supports the digital material management mission. As we become a digital-first enterprise, unifying our approach is the only way we can elevate all airmen to their greatest potential and overcome technological barriers faster to maintain the Air Force's competitive edge. Join AFMC on our journey to digital dominance.
Thank you. Let me go to the next chart and really highlight that our Space Force has the same shared vision for implementing digital transformation. In particular, the Space Force is applying digital strategies and approaches that will integrate their headquarters function, their workforce, their digital engineering practices and acquisition, and digital operations. They have made significant strides, our Space Force partners, in implementing a digital ecosystem and actually implementing a mission-focused approach to their digital transformation. Let me go to the next chart and I can share with you this overarching vision of digital material management or digital transformation across the life cycle. Our digital transformation is inclusive of all of our programs, whether they're new programs just emerging or legacy programs or programs that are in development. What we are asking of all of our acquisition teams are to implement digital practices, either born digital if you're a new program, or adopt digital practices as they can provide value to programs that are under development or in sustainment. And this is really working fantastic. We have multiple success stories ongoing and completed. And we're seeing great benefits in schedule acceleration, as well as an ability to be more reactive and iterative with our technology improvements, cost mitigations, and other such opportunities. This chart shows that we can apply digital approaches not only to legacy or new programs, but across the full life cycle of our program activities. And we can also integrate all of our major functionals, such as our requirements functions, our logistics functions, our engineering and test functions, as I mentioned before, manufacturing. All of these major functions that come together during a program's life cycle can be brought to bear much earlier and then much more continuously, underpinned by a shared digital environment and tools that are able to make exchanges of data throughout that life cycle. This iterative engagement extends into the operational community. And so you'll see at the very top left, we mentioned a mission engineering approach. The true, really disruptive opportunity that digital transformation can bring is the ability to synchronize much more closely between our acquisition community and our operational community. We are employing digital model-based approaches in the way that we derive our concepts and our requirements, and then be able to immediately derive these into system specifications. And so this iterative engagement among our operational community, our science and technology community, and our acquisition communities is enabled by digital transformation, and not just in the DoD, but with our industrial partners and our academia as well. Let me go to the next chart and talk a little bit more about mission engineering. We're actually reorganizing around a mission engineering construct. This is part of a new organizations that are being stood up right now in the Air and Space Forces. Space Force Futures Command is being explored, and the Air Force has implemented an Integrated Capabilities Command. These two commands are new constructs for integrating our critical operational priorities and deriving the future force designs for how we will implement and meet those critical mission priorities. So these two commands are deriving from the joint warfighting concept, critical air and space missions, and they're using model-based systems engineering to do so. They're creating mission threads that represent how our capabilities must come together through doctrine, organization, training, leadership, and materiel solutions. So the full DOT-MIL-PF, some of you might be familiar with that acronym, but the full sort of organizational and mission activities necessary to bring to bear a capability are all being derived and conceived digitally. And then we're implementing a mission engineering approach to take these mission threads and then decompose them into the the systems and the materiel capabilities, the tactics, techniques, and procedures that are all necessary to bring to bear that mission capability. This digital approach allows for traceability from concepts through the mission threads to the mission engineering threads. And the digital representations enable us to perform modeling and simulation and quantitative analysis that provides us with key metrics and insights about the mission performance and the system performance. Let me go to the next chart. All of the services in DoD and OSD are employing a renewed emphasis on mission engineering. And the Air Force and the Space Force and the other services are deriving their mission engineering approaches and practices from a common set of guidance. So depicted here is the DoD Mission Engineering Guide. And this provides us with common definitions and approaches, and this really facilitates cross-service and joint implementation of the mission engineering approaches and architectures and the digital models that are being used to assess the mission threats. There is much work to be done here. I'm really excited about mission engineering and employing system of systems engineering approaches, as there's a lot of my history and my career has been spent on advancing these approaches in our engineering practice. But there is more work to be done. We have got to be able to enhance our processes, our tools, to be able to manage aggregation of multiple missions. There's core functions, there's enabling functions, there's foundational capabilities. There are many-to-many attributes when we're aligning systems to missions. And so this really creates a very challenging environment for our engineers and our decision makers to really prioritize and design to. In addition, there's important work ahead on digital tools and environments. We've got to build our networks so that they can integrate across functions with industry and government and at multiple levels of security. We're needing to enhance our constructs for managing data, trust of data, validation of data, and sharing of data. And in doing all of this, we are needing to also be able to adapt our business practices, our decision-making practices, and our workforce and our training and our stakeholders. Kind of the cultural transformation that is necessary with digital transformation. On my next chart, I want to drive into another aspect of our digital transformation approach, and that is use of modular open systems. MOSA, as the acronym is stated. This is a critical. We are leaning forward in the Department of the Air Force and making MOSA, or open systems and government reference architectures, part of our foundational acquisition approaches. So we are putting these GRAs, government reference architectures, and open standards on contracts, and they're part of our acquisition strategies. We have published a digital building code, and this digital building code provides expectations to all of our acquisition programs for implementing a digital approach, which includes model-based engineering and model-driven engineering, digital engineering approaches, also open architecture and open standards approaches, and agile software or agile development practices. So this is all outlined in the digital building code. And also our Air Force Materiel Command has published a MOSA guidebook. And so these lay the foundational framework and expectations for our acquisition programs to implement modular open systems approaches. And in the bumper sticker here, I'm highlighting for you several of the emerging government reference architectures that are being placed on contract. Our Agile Mission Suite is now being used for our future aviation platforms. This builds on the open mission systems approach and our government avionics reference architecture that has been in use for a number of years now. We have a autonomy GRA that we are implementing for autonomous and semi-autonomous platforms. And we have also developed and proven a weapons open systems architecture for our munitions portfolio. So these are three really important examples of GRAs that we are committed to and implementing on our acquisitions. We go to the next chart, and I'm going to just go one level deeper into one of those three that I mentioned, which was the Agile Mission Suite GRA. It's built, as I mentioned, on the foundation of open mission systems architectures, which have been implemented in a number of our emerging avionics platforms. But this Agile Mission Systems, our Agile Mission Suite GRA, further decomposes that open mission systems approach down into the software modules. So we don't just stop at sort of the black box component, but using more kind of commercial approaches, like think of a cell phone and app approach. We are able to provide and facilitate much more frequent updates, much more streamlined approaches, and reduce the risk of vendor lock. So with the AMS GRA, we'll be able to assess compliance of software. Software will be developed by any vendor, and vendor compliant software will be able to run on compliant hardware. And we believe that this is going to increase our speed of delivery of capability and our ability to react to changes in the threat or changes in technology, and can have more continuous upgrade of our weapon systems. We'll be able to improve at the speed of software rather than the speed of hardware. Now let me go to my next chart, and I want to talk a little bit about how we can't do this alone. To be successful, we've got to be able to integrate our digital transformation not only across the DoD, as I mentioned, with our service partners and with our international partners, but with all of our external partners. Most importantly, our industry partners. So we have taken the great step, really lean forward to establish forums for shared engagement and collaboration. Specifically, this chart lists, and there's 2 QR codes here. We have established an industry association consortium, or an IAC, we call it. And we've also established a digital acceleration consortium, or the DAC. And the 2 QR codes will take you to more information about each of these collaborative communities that we are building. The first, the IAC, is really meant to be a collaboration of industry and academic associations that have been working on digital engineering, digital transformation for years now, and working on all the challenges and trying to and trying to address them and trying to advance the state of the practice of our digital approaches. But what was happening is we were proliferating all of these activities, multiple working groups. And so the notion of this industry association consortium is to bring together all of these industry and government and academic and other association activities in a way that we can collaborate and communicate transparently. We are meeting as we can when these in major conferences and events. And I'm so thrilled that our next IAC meeting is actually going to be at this conference tomorrow night, and I look forward to being able to kick it off. Our DAC on the right-hand side, or this Digital Acceleration Consortium, we do know that some of the challenges that we face will require more detailed efforts to actually develop processes, tools, and prototypes to prove out our standards and our digital approaches and our ability to secure and share data. And so we announced a Digital Acceleration Consortium earlier this year, and there's quite a few companies that are already participating, and we're really excited about this consortia to be able to expand from beyond just the Department of the Air Force, hopefully expanding to all of our DoD partners. And next chart, and I believe this is my last chart before we can take some questions, is when we started to pull together our community in these association consortiums and do all this outreach, one of the things that we wanted to do was assemble and really kind of focus on in a consistent way what the key challenges are that we've got to overcome in order to make progress and in order to really realize the full benefits of digital engineering, model-based engineering, and digital transformation approaches. And so what's depicted here is the 7 key focus areas for attention of our outreach. And so every time that we are meeting in these consortia with our partners, we're now focused on making progress in these key areas. And we've developed roadmaps for many of them that allow us to track our progress and really collaborate in a much more focused fashion on making change and taking on challenges and having everybody be able to contribute to a coordinated roadmap of outcomes. Some exciting efforts that are underneath these very high level areas of digital challenges are a few things that I just want to mention before I close. We're really excited about the opportunity to create digital airworthiness certifications. There's quite a lot of interest, not only in DoD but by our industry partners in taking our historical airworthiness practices and being able to apply digital modeling to that practice, being able to design our systems and apply GRAs in a way that enables much more streamlined but well and deeply rigorously informed airworthiness certifications. And so this is one of the projects that we're working on, and I'm really hopeful that we can cohere quite a few projects that have been initiated and have been going on in our community towards a common, forward-leaning approach for leveraging digital technology and airworthiness certifications. Building on that concept, we are also really interested in how we might apply a unified certification approach So right now, our systems have to be not only certified for being airworthy, but also some of our systems have to go through nuclear certification reviews. All of our systems have to go through cyber security certifications, and then there's safety certifications. All of those certification approaches are founded on the basic system data that composes the capability that we're delivering. And so to the extent possible that we can share and apply sort of digital model-based approaches to maybe a unified certification approach, we believe that there could be tremendous streamlining opportunities and maybe even cost savings. And then finally, just digital standardization. We have quite a few initiatives right now that are thinking about how do we modify the way that we employ standards or the way that we articulate and maintain our standards, our handbooks, our mil specs. We really want to transform the way that we do this into a much more digital approach. And so those are just a few of the projects, of many projects that we are working on just to hopefully inspire all of you at this conference. I'm so pleased again to be able to share these initiatives with you. They are not just about the Air Force, they are about our DoD ecosystem, all of us bringing together the most advanced practices that we can to improve our ability to accelerate delivery of capability to the operational users that need it. Thank you so much, and I look forward to your questions.
Thank you, Kristen, very much. I feel more educated already this morning, very early. The QR code is up there. I see a lot of questions coming in already. I invite folks to continue to input their questions and upvote the ones you like. Kristen, I just want to hit on, I love what you said at the very end. And before I dive too deep into the questions here, maybe you're familiar with AIAA has been very instrumental in a certification by analysis group here. And so I find it fascinating that the Air Force is looking at the digital transformation of airworthiness. NASA also has its own airworthiness standards. And of course, everybody's looking for how do we get work with the FAA and provide that information to them so it will become, go into the commercial sector. And I just curious how your thoughts are. Are you working with specifically the FAA to transfer this information?
We are. So our airworthiness, technical airworthiness authority is very engaged with the FAA, and so we're aware of, or we're setting the foundation for partnering with them. They're very interested in, kind of enabling, tools that can enable this process. And I'm so glad that you just mentioned not only the AIAA work, but NASA. Because as I was talking, I realized that I didn't mention our federal agency partners. So DOE and NASA and many others, Department of Homeland Security, we are all really partnered across the federal government in this digital transformation. And so NASA is a terrific partner here as well.
Yeah, thank you. Wow, the questions are really coming in. And those of you, so I see Kristen in a very large screen here. So if I'm looking down at her, it's not because I'm being rude. There's probably, a couple thousand people in this room right now, Kristen, just so you know, they're all here to support you. So a lot of questions here. Let me see if I can find some good ones. So how do you recommend sustaining the digital transformation efforts when funding and enthusiasm begins to wane? And I'll add a piece on that because I've heard, everybody's into the digital transformation. It's lots of buzzwords, but I hear things like companies get stuck or organizations get stuck. They've digitized a whole bunch of stuff and they've maybe connected a few things, but how do you, and my thoughts, drive that cultural change? So in that, how do you keep the funding efforts going? And also, do you have any recommendations how people can take the full benefit of what digital transformation offers?
Yeah, this is really we've got to keep the momentum going, and so I mentioned a couple of things that we knew were critical. One was policy, putting it into policy, putting it into regulations that are required, expectations, and so that's been our focus. One of our key initial focuses was to set those expectations and communicate loudly in a committed way, not only to our program managers and our program teams, but to our industry partners that are delivering on those contracts. So we are doing that. That's one thing. But you also mentioned resources, and so this has been and will continue to be a challenge. But there's been such broad interest in making these advances that the Department of the Air Force has actually been able to establish a budget line item in our appropriation that is now able to fund the provision of common tools, enterprise tools for our acquisition community, and so that's one small step. There is other investment that needs to be made in the building out of digital environments, and some of those challenges that I mentioned about multi-level security capability. We don't have those things fully funded now, and so what we are actually doing as a result of that is individual programs or maybe program executive offices are making investments through the programs that they are funded, for. And but so what we're really driving is to try to, if we are going to make investments in a particular domain or area, we are doing that with the mindset that ultimately we want to be interconnected across the enterprise. So there's definitely, it is helpful to have the full support of our whole community, the associations, as well as your constituents, for setting the expectation that some of these there is an expense, there is a cost to implementing these digital approaches. But as I mentioned, we have to invest not only in what we are acquiring, but how we are acquiring and our improvement of our business practices.
Thank you. Thank you for that. I'm going to switch gears here a little bit. You did talk about the Air Force. I guess this would be the Air Force and the Space Force 10-year STEM outreach plan. Can you share a few more details about that plan? We do have a lot of students here that are attending, and we'd love to hear how you guys are engaging.
Oh, great. Well, I am so excited about our STEM workforce, our talent development. And one of the things that we implemented was a program called the Legacy Program. One of the things I'm really excited about is that we have, and all the services have, active engagements in STEM initiatives. But what we wanted to do, and what we've been successful in doing, is implementing something that we're calling this legacy approach, where just like you would imagine our sports teams. So you're having an event tonight about your who's your home team or who's your alma mater. So for sports, recruiters go out and they track our young athletes, our young students. We want to engage with our young students, not only individually on STEM projects when they're in elementary school or when they're in middle school, high school, and college. What the Legacy Program does is invites those students back and connects them to become, as they are very junior STEM partners with us, or participants, and then they become apprentices, junior apprentices, and then interns. And what we found is that's helping us to attract our young, our future generation of talent to the Air Force. Not only just to go stay in STEM, but STEM in the defense field. So that's one example of our initiatives.
That's great. Yeah, thank you very much. So one, I'm going to scroll down a little bit. I see a few here at the bottom that are coming in that are pretty cool. How do you manage digital vulnerability to your adversaries as we push the edge with the digital transformation? That was one I think a lot of people have thought about that. The more you provide the digital transformation across your organization, some people say the more vulnerable you are to cyber attacks and things of that nature too. So how are you handling that?
Yes, and we have to implement that cyber resilience.
Yes.
To and really managing our data. We can't just rely on network and perimeter defense. We've got to be able to implement and manage the security of our data. And so these environments that we're building and the way that we classify and manage data is a key foundational element of our digital transformation approach. We have to be agile in the way that we can maneuver to respond to cyber threat, cyber attack. The types of tools that we employ we have to understand their provenance, and so this has just got to be built in as part of the environment. We've got to be able to continuously be aware of and adapt. And so I would say that just bottom line is that we are absolutely applying cyber security hygiene best practices in a continuous fashion into the way that we're building this digital transformation. And just as the cloud our cloud platforms and our service, our digital services are containerized and are implementing these cybersecurity techniques. We just need to make sure that as we connect across these environments, that we maintain a focus on that security.
Yeah, no, that's great. In the same vein there, I see a question here that's got a few votes. Can you elaborate on the policies and approaches incorporating AI into the DoD's systems, especially with your, I believe it was government reference architectures, GRA.
Right.
Yeah, and working for the government, it's, we have different rules about AI and how we can use it, and then the populace is using it in a lot of ways that are helping them with every day, just as simple as your team's meeting, taking an AI person or AI to take notes. Like in the government, you're not allowed to do that. So things of that nature, to make our lives easier, we want to use these tools, but we need to do it in a way that we maintain security. So yeah.
Absolutely. Yeah, absolutely. That we are kind of moving out to leverage AI, whether it be just to improve our business practices, note taking, contract writing, or operational capabilities like our future autonomous, collaborative autonomous aircraft systems. So all of our PEOs are in the Air Force and Space Force right now are exploring how these new tools and this emerging capability of AI and machine learning can be safely and effectively applied in each of their instantiations. Those types of standards and safety, as well as security needs that are demanded by AI, or the rule set for how they can be implemented, when they can, how all of that is being worked in the autonomy GRA that I mentioned. And so we're taking special mind. In fact, that's why, a GRA has a benefit, because we're able to provide, kind of foundational standards and rule sets and that can underpin all of our systems. We're not reinventing each, or kind of, tweaking and differentiating everything. We have this common foundation. So that's a little bit about what I can say there. It would probably take another different lecture to go into the details of AI/ML, but there's a lot of work to be done there, making sure that we have an ability to test and validate and verify these new approaches and systems.
Yeah, and you've already mentioned that you're partnering and trying to share this data with the commercial world as well. And I love that you guys are, so she's going to be here later today. And then, of course, we already mentioned that the consortium is going to meet tomorrow. I think I heard 6 to 9. So invite folks to check that out. I'm going to switch gears here a little bit and go back to our students and young professionals. What recommendations, as a high-level person in the aerospace world, what recommendations that you have for our students and young professionals as they embark on their aerospace career?
So from this digital focus, my recommendation is that to embrace everything that you're learning and all the new techniques that you're currently engaging with in your research projects, in your capstone design projects, or in your academic activities, and we look forward to bringing all of your new knowledge and experience to the services. But beyond just digital, there is such a tremendous opportunity. So I am in my 33rd year of service with the federal government. My career has been fantastic. I've had the opportunity. I started in the Army as an engineer. I moved to positions in engineering and production and manufacturing, and then science and technology. And now I'm with the Air Force and Space Force. The opportunities in DoD and in defense are fantastic and enduring. And and I can also say that the variety of opportunities that you can get from a technological expanse are just tremendous. If you want to get your hands dirty, we've got all kinds of not just software and data modeling, but testing and evaluation and field work and opportunities to deploy. And so I just can't say enough about this defense community and the opportunities that are there, and they're not going to go away. And we're at a time right now in the world where we are feeling a very strong sense of urgency about the criticality of our workforce and our technology, and the ability to field critical capabilities to our warfighters in order to compete with peer competitors. So there's a national sense of urgency here, and I can't say enough. So I appreciate that question.
Yeah, thank you. I'll echo the variety piece, working throughout the government. Yeah, it's pretty cool, the variety of things you can get involved in. There's one question that's way up at the top, and I'm saving it. So it's fun. It's a fun question. So we can end on this, but from your point of view, given the advancements in real-world science and technology, what do you think is the most feasible technological innovation from the Star Wars universe that could be developed within the next 50 years? And what challenges would engineers and scientists face in making it a reality? That's a super fun question. We could ask all of our plenaries this question.
Gosh, one more cup of coffee and I could have tons of more ideas. But I love the idea of robotics, and imagine holograms, right? So I would just go right there. And if we can have, we will have such communication capability to project our engagement across dispersed and separated forces and communities. And I think the application of the advancement of robotics as well as holograms can really help to transform the way that we support our forces. When we think about some of our future, this urgency that I mentioned, this national security urgency, we believe that we're going to find ourselves in situations where we are not going to have an ability to, ship over, kind of wait for the delivery of future capability. We're going to have to, kind of remanufacture, regroup, reset in place. We're not going to necessarily have the luxury to bring things home and wait for that. So this ability of operating in contested environments with Star Wars technology is going to be really important.
Yeah, thank you. R2D2 and C3PO, they're coming our way. Thank you, Kristen, very much. I mean, I've learned so much in a short amount of time, and thank you for sharing your message today. Look forward to seeing you later today as well.